Lesson 40, Statistical Analysis Techniques. In the remaining lessons of this course, additional statistical analysis techniques will be introduced to extend and enhance our understanding of and experience with inferential statistics methods. Topics which we covered in these upcoming lessons include a one-way analysis of variance. A one-way analysis of variance is used to determine if the means for more than two populations are all equal. This is accomplished by conducting a hypothesis testing procedure. Now, in previous lessons, we've learned how to conduct a hypothesis testing procedure involving one population mean and hypothesis testing procedures involving two population means. Now, with the introduction of a one-way analysis of variance, we'll be able to conduct a hypothesis testing procedure involving three or more population means. The chi-squared goodness of fit test is a hypothesis testing procedure used to determine if the expected frequencies fit the observed frequencies. Now, chi-squared test is used to analyze qualitative data. And in the chi-squared goodness of fit test, predictions are made according to some theory about the percentages of each of the various categories in the qualitative variables. And then sample data is collected to observe the actual results. The chi-squared goodness of fit test allows us to test to see if these predicted or expected frequencies reasonably fit or match the observed frequencies. If they do, then the idea used to generate these expected frequencies is considered to be a good idea. Now, the predictions in the chi-squared goodness of fit test generally involve predicting the proportion or percentage of each of the categories of the qualitative variable. Now, in previous lessons, we've learned how to conduct hypothesis testing procedures involving one population proportion. And we've learned how to conduct hypothesis testing procedures involving two population proportions. Now, with learning the chi-squared goodness of fit test, in a sense, we'll be able to conduct a hypothesis testing procedure involving ideas for three or more population proportions. The chi-squared test for independence is used to determine whether two events are independent of one another. Now, in earlier lessons, we've learned the idea of independence. And at that time, we informally made conclusions based on whether events were independent or not by arguing whether the probability of the E given F is equal to the probability of E without the given F. But now that we've learned formal hypothesis testing procedures, whenever we want to test whether two events are independent of one another or not, we will use the formal chi-squared test for independence. Now, the chi-squared test analyzes qualitative data that fits categories. So here we're determining whether these two qualitative variables are independent of one another. This allows us to determine whether there's a relationship or some association between these qualitative variables. Finally, linear regression analysis. Linear regression analysis is used to predict one variable based on the linear relationship with another. In linear regression analysis, the data involved is quantitative variables. And here, if there's a linear relationship that exists between these variables, we can use that linear relationship to use one variable to predict the value of another variable. Entire courses are dedicated to learning and understanding each of these versatile and powerful statistical analysis techniques. Therefore, the remaining lessons in this course cannot possibly cover the entire scope of these complex and involved statistical analysis techniques. Instead, these upcoming lessons are intended to introduce the student to the fundamental concepts involved in and the basic application of these useful statistical analysis techniques. So let's take a look at these upcoming lessons.